Hello everyone. In this lecture, we will talk about some action selection strategy. So what we have seen so far, like we have seen how to form estimates for the bandit mean rewards. So now we will discuss some action selection strategies. So what are the some of the famous action selection strategies? The first one is using greedy approach. So the first baseline is fixed exploration period plus greedy strategy. So here we allocate a fixed time period. So we allocate a fixed time period to exploration. I hope now you will understand, about exploration and exploitation. So exploration is like exploring new things, and exploitation is choosing the best thing. So for a fixed exploration period, so first we allocate a fixed time period to exploration when we try bandits uniformly at random. So this is a step one. Step two, we estimate mean rewards for all actions. So we towards each action. So action denotes pulling the arms. So and we estimate the mean rewards. So you can see this is the formula of the mean of the all rewards. So this is total number of times that the arm is pulled, and this is the average of all rewards for each action. Then we select the action that is optimal for the estimated mean rewards given all data thus far, breaking dice at random. So we take the optimal mean reward, and the next step is just go to step 3. So this is in exploration phase. So now, so the fixed exploration period plus greedy strategy is a simple approach to solving the multi-arm bandit problem, and it consists of two phases, like an initial exploration phase where the agent gathers information about the rewards of different actions, and followed by a purely greedy exploitation phase where the agent always selects the best action with highest estimated reward. So, in the exploration phase, the agent explores all available actions uniformly for a fixed number of steps, and in the exploitation phase, the agent switches to a greedy strategy. So this is called fixed exploration plus greedy. So greedy means choosing the best, like um, best action, and how they choose the best action that they get from exploration phase. So this is a straightforward approach to solving the multi-armed bandit problem, and it allows the agent to gather sufficient information during the exploration phase and then exploit the best action based on this information. So, but however, this strategy has limitations. So especially in non-stationary environment. So I talked in my earlier lecture what is non-stationary phase. So non-stationary phase does not adapt to the changes in action values over time. So Q denotes action values, and more sophisticated strategies. There are some sophisticated strategies like epsilon greedy and upper confidence bound. So this can address these limitations. So now we will see our next. Okay, so after the fixed exploration period, we have from some following reward estimates, and then we choose the best reward. So now we will see our next action selection approach. So we can say epsilon greedy action selection. So what is the problem in greedy action? We always exploit. First we explore and then we choose the best. So this is the like fixed exploration period plus greedy. But in epsilon greedy, you are usually greedy. With the probability epsilon, you instead peek at an action at random, possibly the greedy action again. So this is the perhaps the simple way to balance between exploration and exploitation. So I am so what is the key? What are the key concepts? So the epsilon greedy action selection is a strategy for balancing the exploration and exploitation trade-off. The main idea is to choose the best action most of the time, but occasionally choose a random action to discover potentially better options. So how you choose occasionally a random action? So by the help of epsilon. So uh, so there are mainly three important concepts. So one is exploration, like trying different action to gather more information about their potential rewards. Then exploitation, like selecting the action that is currently estimated to provide the highest reward based on past experience. And the epsilon, like the parameter between like 0 and 1 that determines the probability of choosing a random action. So the probability of choosing the best action is 1 minus epsilon. So okay, I will go this. So this is my uh like epsilon greedy action selection algorithm. So first we initialize everything to 0. So this is like k arms. So this a equal to action. So action equal to 1 to k. So we want to pull k arms. And initially like our QA, like QA is action value estimate, and the NA equal to 0. So NA is like count the number of actions taken. So first step is initialization. So initialization, so we set the value of action value estimates and the count of actions, which is n. Then we, with the help of probability, so here you can see like with the help of probability is epsilon, we take a random action, and with the probability 1 minus epsilon, like we are breaking ties randomly, we take the like best uh, action value estimate, like this QA, and then we like take the reward and we go to the next uh, next step, and after executing an action and receiving a reward, update the action value estimate using the reward. So we are updating the action value estimate. So this is the simple algorithm of epsilon greedy action selection. And if you want to counting the regrade, so in the last lecture I talked about the regrade, like the action taken, difference between the action taken and the optimal action. So if an algorithm forever explores, like this always in exploration phase, then it will have the linear total regrade. So this is my linear line. So if an algorithm forever explores, it will be like linear total regrade. And if an algorithm never explores, it will have like linear total regrade. Okay. Now we will talk about contextual bandits. So what is contextual bandits? So in the contextual bandits, also known as like associative search, extend the multi-arm bandit problem by considering the contexts of features available at each decision points. In a standard multi-arm bandit problem, the agent selects an arm based on past rewards, but in contextual bandit, the agents also considers the current context and when selecting an arm. So in contextual bandit, so context plays a vital role. So context is like information or features available at each decision point that can influence the reward. For example, in a recommendation system, the context might include user preferences, time of the day, and user history. And the action, so the action is like the different choices available to the agent. So in case of multi-arm, like pulling the arm, and each action can have a different expected reward depending on the context. And the rewards are like the feedback received from the environment after taking an action. So the key concepts are context, action, and reward. So so here you can see like, so the contextual bandit is a tuple of action, state, and reward, ASR. A is known of set of action, which is arm. S is the probability of state is an unknown distribution over states. So here we are seeing like context. So we are adding some contexts. And these are actually the reward distribution, like probability of reward given state and action is an unknown probability distribution over rewards. And each time t, environment generates state st that belongs to set of states. Agent selects action AT that belongs to a set of action, and environment generates reward like RT is like set of rewards. And the goal is to maximize cumulative reward. So okay, so now tell me, just think now, just what is the difference between like different algorithmic like approaches. So first I discussed about fixed exploration period plus greedy. So that the strategy consists of initial fixed period of pure exploration followed by a purely greedy exploitation phase. Then I discuss about epsilon greedy. So the epsilon greedy algorithm balances exploration and exploitation by selecting a random action with probability epsilon, and the best action with the probability 1 minus epsilon. And then I talk about contextual bandits. So contextual bandits extend the multi-arm bandit problem by incorporating context or features available at each decision points. So I hope just I am give you a task, just write down the main difference between these three like strategies that I have discussed. Yeah, and now I will talk about this real world motivation, so real world problem. So I also discussed some portion of this real world problem like in earlier lecture also. So the problem statement is, so I'm just defining the problem statement. So for a given movie title and a specific user, so you have a movie title and you have a user, decide which image to show on the user's home screen to maximize the engagement. So there are key components are actions. So just think what can be the actions. So the action is displaying one of the available images of the movie for the movie title. Then we have the mean rewards, and we have the some estimated mean rewards like the observed average click rate, which includes like quality management. And as I'm discussing about context, so what should be the context? What can be the context? I hope just pause the video and think that what can be the context in case of this personalized Netflix artwork problem. I hope like you have thought like, so the context are like user attributes, like can be like user attributes such as language preferences or genres of films watched and the time of the day of the week. And yeah, so this is so in this Netflix artwork problem, actually they use like contextual multi-art bandit problem. Yeah, so that's all for this lecture.